Section 7.5, aqueous solutions and solubility. So we learned that that little abbreviation AQ means dissolved in water. So an aqueous solution is a homogeneous mixture of a substance with water. You can have a liquid dissolved in water and have an aqueous solution. You can have a solid dissolved in water. When ionic compounds dissolve in water, what they do is they come apart or dissociate into their individual ions. So here's an illustration of table salt, sodium chloride. When you put table salt or sodium chloride into water, it comes apart into sodium ions and chloride ions, and they separate and they go their own way. There are no sodium chloride units that are floating around. So that's what ionic substances do. When something does this, when it separates into ions, we call it a strong electrolyte. Dissociates completely into ions, strong electrolyte. Electrolyte makes you think of, well, it probably makes you think of Gatorade in sports, but electro is like electricity, right? A strong electrolyte will conduct electricity. Water, pure water, is not a good conductor of electricity. I mean, it will conduct electricity from like lightning, because that's a huge amount of electricity. But smaller amounts of electricity, water is not a good conductor of electricity. And so if you set up a deal like this with a battery and a light bulb, and you put the two ends of the wires in a glass of pure water, the light bulb will not go on, because the electricity cannot pass from the one end to the other through the water. But if you throw some table salt in there, it dissolves into ions, and these ions can carry the electrical charge, and the light bulb glows. Okay? If you remind me in lab, I can probably show you this afternoon. Yes?
Is that because of the sodium?
It's because there are positive charges and negative charges. And electric current is the flow of electrons. And so you need something that can allow the electrons to move from one electrode to the other electrode through that liquid. Metals are very good conductors of electricity. Non-metals are not, because, well, it is a long story.
It's positive, so it's attracting them and then...
Yeah, so what happens is one of those electrodes is positive, and the negative chloride ions are attracted to the positive electrode. The other electrode is negative, and the positive sodium ions are attracted to that electrode, and we get conduction of electricity that way. So a solution like sodium chloride is called a strong electrolyte solution, because the substance dissociates completely into ions. Let's look at what happens when silver nitrate dissolves in water. Silver nitrate contains a polyatomic anion, nitrate ion. And so when silver nitrate dissolves, we get silver ions and we get nitrate ions. So it dissociates completely, but not into individual monatomic ions. The nitrate ion is composed of nitrogen and oxygen atoms that are covalently bonded together, and they stay together even in solution. So those polyatomic ions, and that's why we name them as a unit, and we put parentheses around them. The shrink wrap is still on them from Costco, the bundle pack. And you put them in solution, and they separate from the person that bought them, but they're still bundled and shrink wrapped together, and they don't come apart. So those polyatomic ions dissolve as intact units. Silver chloride doesn't dissolve at all. It just sits as a lump in the bottom. The silver and the chloride ions, for reasons that are beyond the scope of this lecture, will not come apart in water. And so it just sits in the bottom. It does not dissolve. We say it's insoluble. That's enough for today.